Number 23. It is our favorite. We just love these types of problems. We just love these types of problems. Let's go ahead and graph this little guy. This cute little guy here. All right, so I have graphed it. It is a pretty curvy line. It says where is f of x greater than or equal to 0. Probably the easiest thing to think about is going to be where does it equal 0. We can start there. So if it were to say just where does f of x equal 0, what does that mean? If it says where does f of x equal 0? What? Where does y equal 0? What does that mean? You're close. Where it crosses the x-axis, what are the x-intercepts? So the x-intercepts are going to be really helpful for this question. So let's go ahead. There's 3 of them. We're going to need all 3. So we're going to need this point right here, and this point right here, and this point right here. And the reason we need those points is because that is where x is equal, f of x is equal to 0, which is part of this answer. We're going to need all those points. Yes? Broken? Does the screen have a little smudgy on it?
No.
Smudgy screen? Oh.
No. I retyped it and then I cleared it and
okay.
then I retyped it again.
You guys ready for some math magic? Here's the math magic. Second plus 712. Bam. You ready? Negative x to the 5th. Plus 4x to the 3rd. Minus 2x minus 1. Boom. Graph. Boom.
What did you say? What did you do?
I cleared it, and then I typed it again. That is the magic that I do. I clear the memory, and I type it again. I am very magical. Second plus 712. Yes, all right. So the first 0, is it actually negative 2? Did anyone find it? It is not actually negative 2. It's a decimal. All right, negative 1.895. And then we've got this one right here and this one right here. Okay, so the next one is very close to 1. Oh, it's at 1. That one is actually at 1. That's cool. And then what's the last one? .789. So why was 6 afraid of 7?
79.
Look at us, same wavelength. Okay, let's go ahead and do this problem. So what part of the graph shows where f of x is greater than 0? So where is, and this is the y value, right? So where is the y value greater than 0? It equals 0 exactly right here. Where is it bigger than 0? Where is the y value bigger than 0? You don't have to tell me the answer, because that might be hard for people. Can you just describe it to me on the graph, like tell me where to look in like layman's terms? Above the x-axis. So this part right here, Jack, you were just being real advanced real fast, so I wasn't ready for it. That part right there in blue is the answer. We just have to figure out how to write it. Okay, so Jack, you started with the negative infinity. Negative infinity. Okay, what else do we write? Okay. Parenthesis around the negative infinity always. Now, based on the way it's written, should we put a bracket or should we put a parenthesis with the negative 1.895? Bracket, because we are including where the function equals 0. Does that make sense? We're including it. Okay. How do we do this other little, like, right here? We got a U because we got another answer, and this is interval notation. And then what do we put? 1. Brackets or parentheses? Brackets. Okay. All right, now it says, where is f of x negative? They're asking the opposite question, but they're doing it in words instead of using the inequality. So they could be saying, where is f of x less than 0? But they didn't say it that way. They just said, where is it negative? It is the other part of the graph. It's this part right here. It's that part. So let's go ahead and answer this part of the graph. This is going to be the red. So how do I answer this interval here? From the blue dot to the blue dot, but just the underneath side. Negative, or to positive 1. Positive 1. That's what you meant. It was a typo. It was a typo. That's what you meant. Okay. Brackets or parentheses? Parentheses. That's good. That's good. Okay. Because when y equals 0, it's not negative. It's just 0. 0 is neutral. It's not negative. It's not positive. It's neutral. Okay. So this is the first interval from negative 1.895 to 1. That's the first little red part that's underneath the x-axis. Okay, now we have to answer this red part right here. So I'm going to put a U. I got a second answer, and how do I write it? 1.789 to infinity. Yep. So this is infinity right here. Parentheses, brackets, what do we put? Parentheses. Perfect. Okay. Now it says, where is f of x 5? So that's a y. Where's the y value 5? And so we can kind of see it. It's right here, right? That's where we have a y coordinate of 5. So the way that you find that on your calculator is you take your calculator, you hit the y equals button, you go down to y2, and you hit 5. So what your calculator is going to do is your calculator is going to graph a horizontal line at 5. It's going to do this. It's going to graph a horizontal line at 5. And what we're going to do is we're going to find the intersection of that horizontal line with the curve. And then that's going to tell us when the function equals 5. So we're going to graph that. There's that horizontal line. How do we find the intersection of a curve and a line? Second trace. Number 5. And I press enter, enter, enter. Boom. Okay. Now, remember, whenever it says the questions, where is, whenever it's asking that, it's asking for x values. X values are always locations. So where does f of x equal 5? All you have to say is x is approximately negative 2.054. You could also put the point, negative 2.054, comma 5. That would be fine as well. It's kind of like somebody saying, hey, what's your name? And you answer your first and your last name instead of just saying your first name. Kind of like saying both. Yeah. All right, Court, yes? Did you have a typo in your problem? Does it say guess or does it say intersection? It should say intersection if you've done it correctly. Shouldn't just, if you're scrolling around, if you're trying to get it by scrolling around, then it's not accurate. You have to get it by doing second trace number 5. Yeah. Getting it by scrolling around will get you close to it, but it won't get you exactly right. Your decimals will be wrong every time. Okay. All right, any other questions? Be good? Okay. So you are not going to turn this in just yet. You need to do 24 and 25 still. So you're going to hang on to this, okay? Yes. Yeah. So y2, I put 5 for y2. And it made that horizontal line. And now I just have to see where they cross. And the way that I see that is I do second trace. option number 5. And since there's only one place where they intersect, you don't have to move the cursor at all. You can just let the calculator do its work. So once I hit second trace number 5, I'm not doing anything but hitting enter. So look, see it's on my screen? And I just hit enter, enter, enter. And then when I look back at my screen, ta-da, the answer's there. The only time you have to move the cursor around is if you have more than one intersection. Then you have to tell the calculator, okay, find the left one, find this one. And then when you find the other one, you have to tell the calculator, okay, now look over here because we're finding the other one now. But if there's only one intersection and it's a pretty normal graph like this one, you don't even have to move the cursor at all. You can just press enter, enter, enter. And the calculator's like, yeah, there's only one answer. You're right. I know exactly where to go. Okay, so we're going to hang on to this because I do want you to do 24 and 25, I think. Hang on to them. Maybe make a pile. We'll see if we're going to turn the pile in or keep the pile. We'll start making the pile with that. Okay, now last night you did 1 through 6, I believe. Okay, you're going to save this. Tonight is, I believe, 7 through 10. So we are not turning this in. Tonight is 7 through 10, okay? So write 7 through 10. Remember to write 7 through 10. We've done 1 through 6 already. Tonight is 7 through 10. And then put it off to the side because we're about to do some notes. No. LOL, no. How did we do on 1 through 6, though? Was 1 through 6 okay? 5 and 6 were... The negative... Okay, so just for some confirmation that you were on the right track with number 5, because I do think that was probably the hardest problem out of the 6 problems that you had to do. It said third degree polynomial. So this is the information they give you to start with. The second answer, remember we have to think of the quadratic formula. You have to think about where the signs came from. So the -3 came from this spot, and the 5i came from this spot, right? So when we're thinking about our answers that come in pairs, what's the other part of the pair? The other part of the pair is -3 minus 5i. But the -3, you'll notice, is actually the same, because it comes from the beginning of the quadratic formula, which is the same regardless. Okay? So that I could see being a little bit tricky about number 5. The other thing you need to make sure is when you put it in parentheses, you have x plus 3 minus 5i, so we're doing opposite sign of both of them. X plus 3 plus 5i, and then x minus 7. I'm not doing any more than that because that was your homework. You should have done that. Yes? Because remember, these don't necessarily come in pairs. These don't have to come from the quadratic formula. That can just come from factoring. So the ones that come in pairs are specifically, it came from taking a square root. I's, no matter what, the I had to come from a square root. The 7 did not. The 7 could be from factoring. So it didn't have to come from a pair. Okay. This one, quadratic, you have +4 square root 11. You should also have -4 square root 11. Okay. All right. So last night you should have done 1 through 6. If you did not do 5, you now have some helpful hints to be able to do 5. That was the most difficult part, I think, from last night's problems, was setting up number 5. So tonight is 7 through 10. Go ahead and put that away, because today we are doing application problems. I do think, put the characteristics in a pile. Depending on how much time we have to work on today's assignment, I may or may not have you guys do 24 and 25. I am not sure yet. I do want to make sure that you are okay with doing those types of problems, though. All right. Let me hand out the notes. So, we are doing application problems. We have two types of situations that typically happen with application problems. So the first one is called projectile motion. You can even write that above it. This is a projectile motion problem. Projectile motion. So it says a water balloon is catapulted into the air so that the height in meters after t seconds is modeled by that quadratic equation. Sketch the path of the water balloon on a set of axes before you begin answering the questions. All right, so it's catapulted into the air. So you have the water balloon is probably not, it's not on the ground. We'll say there's the water balloon. It's catapulted, and what would the path of the water balloon look like? Yeah, it like goes up, comes down. All right, so what is happening here? Okay. Up here, this is like the highest point. It's the highest point that it got. This is where it was launched. Okay. So we've got our splat when it hits the ground. We've got our highest point in the air. We've got our launch. They told us, so our input, they're not using X's and Y's here, they're using T's. So I'm going to say that T is what we normally think of as X's, and that they're using as seconds. So T, they're using where we normally would put an X, and they're using seconds. H is where we normally put a Y, and they're using height in meters. It's the height off the ground in meters. So I'm going to go ahead and label that in my picture so it makes sense. So I'm going to say that this is my time in seconds. And then I'm going to say this side right here is height in meters. Just so that I have a general sense of what is going on. So as we answer these questions, we're going to use our calculator for this. So this is not work by hand, this is calculator work. And when we do these questions, we're going to have X coordinate questions, we're going to have Y coordinate questions, okay? X coordinate questions are always going to have to do with time. Y coordinate questions are always going to have to do with height, okay? So based on the way the question is phrased, we're going to know which letter we can plug something in for and which letter we can solve for, okay? So here, if they say, what is the initial height of the balloon, that means we are solving for Y. If we are solving for Y, that means they have to have given us an X value, okay? When they say initial height, what does that mean for time? Start, it's the start time, it's 0. So if this is the initial height of the balloon, that means that X equals 0. So let's go ahead, we're going to start plugging this in. We're going to make sure that we can see all the important parts of this problem. I'm going to give you guys a trick for that on these calculators, how you can make sure you can see everything that you want to be able to see. So negative 4.9x squared. I am not a fan of zoom fit. I'll show you a different method for that than zoom fit. 27x plus 2.4. So here's what I do with this. We have drawn the path that we want to see, right? We want to see it go up in the air. We want to see it come back and splat on the ground. Would you guys agree? So what we're going to do is we're going to hit second graph. We're going to look at the table, and we see that 0 is where it starts. You can see from your Y coordinates, it goes up in the air. Do you guys see that? And you can see it goes back down, and then negative is when it's like it's splatted on the ground. Thank you. And so the X values that we're looking at are between 0 and 5. That's like how long it was in the air. And the highest it went up into the air is a little bit over 39.3, probably. That's it. Probably like 3 is probably not the exact like right highest point. So what we're going to do is we're going to change our window so that our y coordinates, our y max, is going to be something above 39.3. That's a great way to choose your window, so that it actually works out like perfectly so you can see everything. Okay, so I'm going to take my window. Yes. Yeah, totally. Yeah, we can write it down because you just saw it. Spoiler, we just saw it on the table. All right, y max, I'm going to put 45. Everything else, the negative 10s, I'm just going to leave in there. I'm not a perfectionist about my graph being like perfectly centered. So once I can see my y max is good, then I'm set. I don't need it to be centered. Yeah. Oh, I just am plugging the equation in from the problem.
Where are you now?
I looked at the table. I saw that the very highest y value was a little bit above, like was at the very high numbers of the 30s. And so I'm hitting the window button. And for y max, I'm picking a number that is above 39. So probably not 40, that's a little bit too close for me. 45, 50, something like that. I am not going to do, 5,000. 5,000 is higher than 39. 5,000 feels like a good number. That's a little bit extreme. Your graph is probably going to be very tiny if you do that and confusing. Okay, so something like within reason. I'm going to graph it. Oh, there we go. That looks kind of nice. Okay. So we've got that. What is the initial height of the balloon? So we are going to get really comfortable with that menu of like where we can get to stuff and how we can plug things in. So do you guys remember if we do second trace and get to the menu, how do we plug in whatever x value we want? Second trace, number 1. Second trace, number 1. We're going to plug in 0. Get 2.4. So I'm going to write my little, see, these are my notes. This is not an assignment. So you do not have to do this on the assignment, but you do need to write this in your notes so that if you need help later, you can look back at your notes. So we're going to write second trace, number 1, x equals 0. Now, if you want to look at the table, you can do that. If you'd rather not do it from the menu, that's fine. I'm going to always have you guys go to the menu for the sake of consistency, so that I'm not sending you one place sometimes and another place other times. Yes? Why don't you just hit trace? Oh, because I didn't know it did that. Cool, thanks. All right, yes. Your window looks different? Did you change your x's?
My graph in general. I put in everything I thought.
Is this what it looks like? Negative 4.9 x squared plus 27x plus 2.4? Okay, does your window look the same? If you hit window, are the numbers the same? That's why. It's your 5s. So you have the same, it's fine. Your graph is just not as wide as mine. So it's fine. You're seeing the same information. Yours is just like more zoomed in, basically. All right, so let's go ahead and look at the next question. It says, how high is the balloon? Are we solving for y or are we solving for x? We are solving for y. How high is the balloon after 1 second? So what are we plugging in for x? We're plugging in 1. X equals 1. You can look at the table. So this is my habit, is to just always do second trace because it's a menu of options. So I'm going to send you to that menu every single time because it's consistent, okay? So if you can always do it another way. Second trace, number 1, x equals 1. Yes, you can look at the table. The reason I do this is because this works for plugging in decimals, and the table only has whole numbers. That's the reason I do that. All right. Oh, I forgot to write this one down. 0, 2.4. How high is the balloon after 1 second? So after 1 second, what do we get? 24.5. Okay. We're going to come back to this because these answers do not currently make sense. Have you noticed that? What is the initial height of the balloon? 0, 2.4. Nobody? Okay. How high is the balloon after 1 second? 1, comma, 24.5. Nobody? That's not, okay. All right. Those are very weird answers. You would not say that. You would say the initial height of the balloon is 2.4 meters. That's what you would say. We're going to come back and write sentences in a little bit. All right. The next question is, for how long? For how long? Are we solving for x or are we solving for y? We are solving for x. For how long is the balloon more than 30 meters high? So more than 30 meters high, this is the y value, y equals 30. Now, anytime we do this, we have y1 equals the equation. That's what we started with. y1 is always just our equation. Now, we're going to do y2 equals 30. y2 equals 30, like this. Okay, I'm going to draw a little sketch of this because these are my notes. I don't have to do this on every single assignment, but these are my notes, so I want them to make sense. Okay, so that's what it looks like. y2, because when you graph something, you have y1, y2, y3, y4, y5. So y1 is the equation, y2 is 30. And now we're going to do second trace number 5. Second trace number 5. Okay, so to figure out where these points are, to figure out what your x coordinates are when you have a y coordinate of 30, you can just find where that horizontal line crosses your parabola. So I'm going to go ahead and I'm just going to do second trace number 5. And for the first intersection, I can just press enter, enter, enter. It's going to take me immediately to one intersection. Okay? Are we all finding that first intersection? We're finding it? Okay. I'm going to go ahead and write this down. Now, because this question is not just saying when is the balloon 30 meters high, it's saying for how long is it more than 30 meters high. We're going to need more than 3 decimals for this. I'll explain why in a second. So I'm going to write down all of the decimals I can see on my screen. That's all I can see on my screen for that one. All right, now for the other intersection, we're going to have to move over a little bit. So if you hit second trace number 5, to move the cursor, you can hit the left and right arrows. To hop between one curve and the other, you hit the up and down arrows. So I'll show you. I'm scrolling on the parabola, but if I hit the down button, it's going to hop over to the straight line. Okay? All you have to do is you have to get the cursor on one of the lines, and you have to get it close to the other intersection. Once you get it closer to the other intersection, you can press enter, 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 like we did before, okay? So I'm gonna use the line because it's shorter. I don't have to hold down the right arrow for as long. I'm gonna get it over here. I don't have to be on top of the intersection, I just have to be close to it, and then I can press enter, 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 and it will find it for me. Okay, so if the question had said, when was the balloon exactly 30 meters high, then I would say 1.35584, 4.1543641. I would say just those 2 moments. But it didn't ask that. It said for how long is the balloon more than 30 meters high. So we found the 2 moments where it is exactly 30 meters high. But how do we answer this question? Yeah. We're going to subtract them because the actual part that is true is this. This is the whole part of the path of the balloon where the balloon is more than 30 meters high. Does that make sense? So it is on its projectile motion, right? It is launched, it hits 30 meters high, and then it goes even higher. So it's more than 30 meters high. It hits its highest point, it comes back down, and then it hits 30 meters high again, and then it's lower than that. So there's this whole portion of time where it's above 30 meters high. So for us to correctly find this answer, we have to subtract those numbers. We're going to do 4.1543641 minus 1.35584. So the reason that we wrote down more decimals is because if you round in the middle of the problem, then your final answer is not correct. We don't want to round until the very end of the problem. That's how math works, okay? So I wrote down as many digits as I could so that when I wrote down my answer at the very end, it would be accurate instead of subtracting rounded numbers. Are there any questions about this problem? Does it make sense how we knew what to subtract or that we should subtract? Made sense? Okay. So the answer here, we got 2.799, okay? The next question says, what is the maximum height of the balloon? Are we finding the y-coordinate or the x-coordinate? The y-coordinate, okay? So here we're going to do second trace. How do we find the maximum height of the balloon? Second trace. Which one in this menu? Maximum, second trace number 4. Okay, second trace number 4, maximum. The answer is somewhere between 0 and 6 seconds. I'm not sure. I'm just going to let the calculator do it for me. I'm circling the y just because I know the y is the answer that we want. Okay, because sometimes they'll phrase the question as, what is the maximum height? Sometimes they'll phrase the question as, when did the balloon reach the maximum height? So they can phrase the question both ways. They can phrase it so you want the x value, they can phrase it so you want the y value. This time they happened to phrase it so we want the y value. All right, when will the balloon burst as it hits the ground? So where it hits the ground, what is that called? Right there. It's a 0 of the function. It's an x-intercept, right? Where it hits the ground, that's an x-intercept. So we were finding an x-intercept. So we are going to do second trace number 2. It says, when will the balloon? So are we solving for an x value or a y value? We are solving for an x value. This is the x-intercept. Okay, so I'm using this x-intercept over here specifically. So second trace number 2, my x-intercept, 1, 2, 3, 4. You know what, I'm just going to say between 0 and 10. I'm not even going to count. Okay, x-intercept. Okay. Next question, when, what are we solving for? X. When is the balloon 27 meters high? So what y value are we using? Y is 27. So here the y1 is going to be the equation. The y2 is going to be 27. And we're going to do second trace number 5. Now here, they're not saying how long is it more than 27 meters in the air. It just says when. When is it exactly 27 meters high? So we are going to have 2 specific answers when it is exactly 27 meters high. Okay? So the picture looks very similar to the one that we just did a second ago. For the first intersection, I can just say second trace, number 5, and I can just press enter, enter, enter. And then to get the other one, I got to do second trace number 5 again. But this time I'm going to have to scroll over and just get closer to that other curve, or that other intersection. And once I get closer to it, then I can press enter, enter, enter. All right, what I need you to do before I move on is just do some finger stretches. Just some finger, just stretch, stretch, stretch out the fingers. We're about to write some sentences. We're entering English class. Are you ready? Yes. Yeah, basically what I'm doing right now is I'm kind of like mathematically showing my work, which can be as informal as you want because it is not the final answer. The final answer for a story problem is a story answer. So we have to write sentences for all of these. Our sentences need capital letters in the front, they need periods at the end, they need to include like what the question is asking in the problem. They need to be full, complete sentences. Miss Rice, why do we do this? Because in upper level math, interpreting your answer is part of showing that you understand what you're doing. Does that make sense? These are easier to interpret than the math problems that you will do in upper level math. But in upper level math, I'm not training any of my students how to write a complete sentence. My students need to know how to do that by the time they get to me in upper level math. In upper level math, I want to focus on how do we interpret this. Does that make sense? All right, stretch your fingers. Are you ready? Because we got to write 6 sentences. And I know you're going to be whiny about it because, Ms. Rice, this is not an English class. You guys ready? Okay, what sentence should we write for number 1? The initial height of the balloon was 2.4 meters. Why? Because she can write a sentence? I have witnessed you being bullied, ma'am. All right, how high is the balloon after 1 second? How do we answer that question? Now, so we want to make sure that we include the question in the answer. So I'm going to say after 1 second. Yeah. It is very nerdy to get A's on your assessments in this class. It's very nerdy to understand what you're doing in this class. Please feel ashamed of yourselves. Nerd. All right, how do we answer the next question? Balloon is higher than 30 meters for 2.799 seconds. All right, how about the next one? Ooh, the max height? Oh, the maximum. Full sentences, man. Full sentences, no abbreviations. That's right. Iron fist. I'm not your English teacher. You don't have to say the seconds because they didn't ask. That's fine. How do we answer number 5? The balloon. It was launched by a launcher, a catapulter. All right, what is our last sentence?
Nerd. Not wrong. Nerd.
Yeah, I would say the balloon is 27 meters high at. Wait, you corrected him and did not get called a nerd. That's like a double win.
Nerd.
I feel like I have seagulls in the class. Nerd, 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 nerd. All right. Got it? Okay. Do you feel like you understand how you could manipulate the calculator to get the answers that you want it to get? Does that kind of make sense? Would you like to practice some of these because the other type of application problem we have is volume. Would you like to practice these before you go on, or do you just want to finish the notes? You're going to have to practice regardless. All right. The next type of question is volume. Volume questions. Let me make sure I have my props. That's right, so you use props for this. I sure do. I do have my props. Wonderful. Wonderful. All right. Okay. It says, an open box with a rectangular base is to be made from a piece of cardstock. This is the piece of cardstock. Pretend it's not hole punched. It's only hole punched to fit in my binder. The cardstock measures 8 centimeters by 12 centimeters. This is not drawn to scale. This is larger than that, okay? The way that they do this is they cut a square from each corner and they turn up the sides. So it looks like this. They cut a square from each corner, do you see? And then they turn up the sides. And then you go, ooh, it's a box without a top. See that? Ta-da! So they cut the same size square out of the corners, and then they fold. Box. We all see? We see the 3D? Marvelous. Okay, let's go ahead and start drawing. All right, so we've got 8 centimeters, 12 centimeters. That is our starting piece of cardstock. I'm going to draw a second picture. Ms. Race, do I have to draw a second picture too? Yes. Because I said so. You'll see in a second. I'm going to draw it like this. Just 2. Only 2. And you only have to draw 2 this first time. Okay. So these little parts here are the squares we're going to cut out. Cut out this. Cut out this. cut out this, cut out this. Okay, so the original width of the paper was 8. The original length of the paper was 12. All right? When we do volume, we do length times width times height. Marvelous. Okay. All right, so if we look at this, if the original box or the original piece of paper had 8 centimeters width, 8 centimeters, right? And I cut out a 1 centimeter square and a 1 centimeter square, and I fold those sides. What is the new width? Because it's not 8 anymore, right? Because I cut it out, and I cut it out, and I folded it. The new width is going to be 6. Does that make sense? There we go. All right. So I'm going to write this right here. I'm going to say my width is 6. I would put the centimeters, but I don't have space. Okay. The width is 6. We good with that? That makes sense? So over here off to the side, I'm going to write my width is 8 minus 1 equals 6. Miss Rice, do I have to write all of that? Yes. It's going to help you in the future when we make it more complicated. Because you are not in elementary school anymore. All right, this, yeah, but we're coloring Biggie, and he's holding up a gang sign. Literally not elementary school appropriate. All right, this side is a length of 12, right? Length of 12. I cut out the 1 centimeter corners. We got it, right? Cut out the 1 centimeter, 1 centimeter fold, 1 centimeter fold. What is my new length? 10. All right. So my new length is 10, okay? Length is 12 minus 1 equals 10. Miss Rice, do I have to write that? Yes. You do have to write that. Okay. Now this part you have to pay very close attention to. This is where it gets funky. We have a 1 centimeter square, right? 1 centimeter square. Everyone see that? I fold these. What's the height of my box? 1 centimeter. Okay. Height is 1 centimeter. Okay, so if I wanted the volume of this box, how would I get it? 6 times 10 times 1 equals 60 what? Centimeters cubed. Okay. So here are my dimensions. When they want dimensions, they want length, width, and height. So my dimensions are 6 by 10 by 1. My volume is 60 centimeters cubed. All right, that was a good time. Let's try it again. No, it's right. No, it's right. No.
Isn't that bullying?
Yep, I'm allowed to bully you. That's why I became a teacher. I was like, how can I get paid to bully teenagers? And I thought, I know, I'll be a teacher, and then I will get paid. And I was like, not just any type of teacher though, math teacher. I did.
Do you genuinely like doing math though?
I do. Whenever I need to relax, I just sit down and make answer keys. How? I sit down and I'm like, 2 plus 2 is 4. All right. So 2 centimeters square. We start off with 8. We agree? We start off with 8. Okay. And then 2 centimeters square, 2 centimeters square. I cut 2. I cut 2. What is my new width? 4. Okay. So I'm going to write this down. My width was 8. I cut 2 off. I cut 2 off because I'm doing it to each side. So my new width is 4. 4 centimeters. Okay. All right. My original length was 12. Okay, my length was 12. I cut a square. I cut 2 off. I cut 2 off. My new length is 8. Okay. I'm showing my work, so I do 12 minus 2 equals 8. Okay. All right, height. I have a 2 by 2 square. A full, fine. 2. Okay, we got centimeters, centimeters, centimeters. All right, so we've got our dimensions. Let's find our volume. 4 times 8 times 2, 64 what? Meters cubed. All right. Okay, are we ready? We're making it so that we just did was like I think middle school math because we had all the numbers. Now we're turning it into math 3. This is becoming a math 3 question, okay? It was actually to the left. That was the song. No, I wasn't correcting you, Keld. I was correcting James and his lyrics. Oh no, that does to both of them. I was thinking of the wrong song. Never mind, nothing. All right. Now, instead of having a square where we know what dimension the square is going to be, they're saying we have an unknown square size. We are not sure what the dimensions are, okay? So we are going to say the width starts off with 8, but we are cutting off some dimension that we don't know from one side. We're going to call it x. And we're cutting off some dimension we don't know from the other side. We're going to call that x. Because we're still doing the same problem. Still the same piece of cardstock. So we are subtracting off x from one side, subtracting off x from the other side, and so the expression that represents our width is 8 minus 2x. Nope. 8 minus 2x. It would technically be negative 2x plus 8 if you switch the order, but nobody switches the order. People don't switch the order because this is how it's written. This is how like you came up with it, and it's easier to just leave it like that. So I would not change the order. Okay, we have a length of 12. We are going to cut a corner of x off the top. We're going to cut a corner of x off the bottom. So what is the new expression for my length? It's no longer 12. It is 12 minus 2x. Okay. Length is 12 minus x, which is 12 minus 2x. Okay. All right, now this is going to be really weird. This is going to be real crazy. You guys ready? If my square is x by x, then my height is x. Okay. All right, so if we write the volume as length times width times height, nobody really cares what order you do it in, but as long as you multiply the 3 together, we're going to say v of x equals 8 minus 2x times 12 minus 2x times x. Do not FOIL those out. Nobody needs you to FOIL them out. Nobody cares. Okay? Leave them just like that. You will not. I will frown at you for doing extra work. It's like, hey, Corey, oh, hey, you, boy, what's your name? And you're like, my name is Corey, and my social security number is this. Can I get some extra credit? And you're like, why would you give me your social security number? That's insane. Why would you FOIL this if I said not to? That's insane. Yeah, please don't do it. No. All right. So in this problem, the x is going to represent how big the square is that you cut out of the corner. That's what the x in the problem represents. So it is how big the square is that you cut out of the corner. Okay? That's what the x stands for. What does the y stand for? Nope. The volume. because we have v equals length times width times height. You multiply your 3 dimensions, you get the output is going to be volume. Okay? So, and it makes sense because that's how we found our volume for all the other problems. We figured out how big the square was, right? And we figured out our width, and then we figured out our length, and we figured out our height. And once we had all 3 dimensions, we had our volume. Okay? So first comes the size of the square that you're using to make the box. Then you find the volume of the box. That's how it works. Okay? All right. So just like last time we had the time in seconds and the meters for the height, this time we have x, which is the size of the square you're cutting out for the corners. Y is the volume of the box. Okay? All right. What is the volume? Are we solving for x or y? We are solving for y. If a 1.25 centimeter square is cut out, so the x value is 1.25, so what we're going to do, before we even plug that in, we got to switch this from the last equation that we had to the new equation that we have, which means we got parenthesis 8 minus 2x, and then 12 minus 2x, and then x. So I'm not foiling, I'm just letting the calculator use that factored form to graph everything for me, okay? To figure out how big my window should be, I'm going to hit second graph. And it kind of does the same thing. So here, instead of having a projectile motion go up in the air and come down, I have volumes that make sense, and I have volumes that don't make sense, okay? A volume of a box being 64, that makes sense. A volume of a box being negative 20, that does not make sense. Would you guys agree? Okay, so here we can see that 64 is the biggest number on here, so I want my y max to be something bigger than 64. Maybe 70, probably bigger than 70, maybe like 80, something like that. So I'm going to go ahead and hit my window button. Instead of having my y max be 45, I'm going to change it to be like 80. I just like to have a little bit of space above the top of my graph. So once we look at that graph, once we look at the table, we know how big to make our numbers. Yeah. You're good. The right behind you, Hannah, is where the assignment is on the table. It was very professional. A+. Hannah, you're leaving.
Yeah, you're leaving. Nerd.
Hannah, when you finish the video, it's at approximately 57 minutes. You're welcome. All right, so we've got this graphed. How do we plug in a specific x value that we want to plug in? Second trace, number 1. We're going to plug in x equals 1.25. What if a 2.3 centimeter square is cut out? Okay, you don't have to hit second trace again. You can just start typing 2.3, and it will let you just do the next one. Okay. Okay. What if a 4.5 centimeter square is cut out? Okay. Whoop, that's a weird answer. I'm just putting this arrow down in my notes because I'm using the same process for all 3 problems. All 3 of them are basically the same. Okay. We can still come back and write our sentences later, so I'm going to leave that for now. Any questions on how to find those answers for 10, 11, 12? Yeah. to figure out how big the graph should be. So I'm just taking the equation from number 9 and I'm plugging it in parentheses and all. I did. Yep. When we are done with the notes. When we were done with the notes. 8 minus 2x. Are you using this minus right here? Not the negative button? This negative? If you use the other negative, it multiplies instead of subtracts. I don't know why. It's annoying that it has two different ones. Yeah. I'm like, if I wanted you to multiply, I would have said multiply. Please don't do that. Yeah, I don't know. All right, go ahead and flip to the next page. For what size square? Okay, it says for what size square? When it says that, are we solving for x or solving for y? X. Yeah, x is the size of the square. For what size square is the volume the largest? Okay, let's go ahead and figure this out. So if I look at my picture, where on the picture are we going to find the largest volume? Yeah, the maximum. So we're going to find it over here. We cannot look at any of this over here because all of this happened after negative volumes. Do you guys see that? So none of these answers are going to make sense. We can see them on the graph, but if we were to use them, none of them would make sense. So the only part of the graph that we can actually use is this part over here. All right, so we're going to do volume is the largest. What they're looking for is second trace. Number 4. They are looking for the maximum. Now, don't leave your screen like this. So those of you guys who are working ahead a little bit, you have to get back to this answer. I'm going to show you guys a nice little trick. This is a fun little calculator trick. So I need this as it looks exactly on your screen. It says maximum. I can see the x coordinate. I can see the y coordinate. That's what I want on your screen. So there are 3 questions here, right? First question is, what is the size of the square where the volume is the largest? We already know that, right? We know that x is the answer. Now they're telling us that they want to know the dimensions of the box with the largest volume. Am I allowed to use a rounded answer in the middle of a problem? No, I can't. So that means I need this decimal. It is annoying to write this decimal down so many times and then use it in 3 different places. So what I'm going to do from this screen, I want you to hit second quit. Hit second quit. Now hit the X button and press enter. Everybody should be doing that on your calculators. What happened? That's the X value. So we had it on the screen. Hit second quit, and then just hit X. Okay, so now we knew that our dimensions, our width was 8 minus 2x, our length was 12 minus 2x, and our height was just x. So the height we already know is 1.570. For the width, we can just type in 8 minus 2x, and for the length, we can type 12 minus 2x. Yeah, it's tricky, huh? Because your calculator, if whatever you found in your calculator, it will store the very last x that you found. Nice little trick, huh? All right, so I didn't even have to plug it in myself. My calculator did that work for me. Okay. And then what is the largest volume? Oh, there's the answer to that next question. Okay, so we have all the numbers we need. We're going to be able to write our sentence for that one pretty good. All right. Any questions on number 13? Yeah, Alex. Okay, so we have, if we were here, if you were here and it said, on the screen it said maximum, and it had the values, it was just sitting there with the values. If you hit second quit, and you get out of that, and then you hit the X button, whatever you just found, if you just found an x-intercept, if you just found a maximum, if you just found a minimum, if you just found an intersection, whatever you just found, your calculator stores it for just a moment as x. It stores it until you find the next thing. So now if I press enter, it is in there. It's stored in there. So now anytime I use the X key until I find something else, anytime I use the X key, my calculator is just going to use that number. So 8 minus 2x, my calculator is using that number. It's plugging it in for me. 12 minus 2x, my calculator is using that number. It's going to plug it in for me and help me find that length. Yes? Yeah. All right. How are your brains? Hurting? Brains are hurting? All right. The next one says, what size square? What letter are we finding? We are finding x. Okay, what size square would be cut out to give a volume of 50? Okay, so what is the y value? 50. Okay, so we haven't done it yet with this scenario, but we did do it with the other scenario. How do we do this question? We have y1 is the equation, and then what do? y2 is 50, and then what do? Second trace number 5. Okay. So y1 is the equation, y2 is 50. There we go. Now, this answer over here is not valid because those answers came after we had a negative volume. So it shows those because your calculator doesn't know we're doing a story problem. So your calculator's showing everything. Your calculator's like, oh, it's just math. So you have to be the one who's like, this is a story problem. These answers do not make sense. I'm going to ignore them. Okay, so we are only going to look at the first two answers, but we do have two answers. We have two full sets of answers, okay? So I'm going to do second trace number 5. Enter, enter, enter. Let me get the first one. All right, so we have 0.723, comma, 50. And before you get rid of that, it says write the dimensions. How are we going to write the dimensions without a headache? That little trick we just did. Okay, so we got width, length, height. Width is 8 minus 2x. Length is 12 minus 2x. Height is just x. So we already know the height. We don't even have to plug anything in. But now I'm going to keep this number. So while this is on my screen, I'm going to hit second quit. And now if I hit X this time, it overwrote the last X value. I didn't have to clear my calculator. As soon as I found something else on the screen, it immediately overwrote it. So now I can do 8 minus 2x and 12 minus 2x. And there's my new width and my new length. And they're perfect decimals because we didn't round to do them. So not only did I not have to worry about plugging them in I didn't do very much work to plug them in, but I also have very good answers for them. Yes. Yeah. Yeah. That is fine. That's totally fine. So that is the first answer. Now, if we go back to the graph, we got to do it again, right? Because we have two places where that volume was 50. So now we're going to hit second trace, go back to number 5, and we're going to move over and find that other answer. All right, so I'm moving the cursor closer to that one, enter, enter, enter. I'm going to hit second quit, type the X button just to make sure. Yep, it took that X value for me, it saved it. Now, when you do this on an assignment, you do not have to write this every single time. It is good to have on your notes because your notes are what you're going to look back on to understand something, okay? Which is why I'm writing it every single time. So 8 minus 2x, 12 minus 2x. All right, how are your brains? Terrible. So with this, you can't quite mentally check out when you do these. You can't quite memorize when it asks this, do this, when it asks this, do this. You have to think a little bit. But if you can think a little bit, these are mostly, can you manipulate your calculator? Can you figure out how to manipulate your calculator to do what you want? All right. Today has not been very mathy. It has been very calculatory. Have you guys noticed that? Okay, so today we are learning how to take a problem and interpret it so that our calculator can do the hard work for us. That's what this is all about, okay? The last question, what size square? Are we solving for x or are we solving for y? We're solving for x, okay? Would be cut out that would give a volume of 46. Okay, so this is very similar to the last question. We're going to find in a moment how it's a little bit different. So we're going to have y1 is just the equation. Y2 is 46, and we're going to do second trace number 5. Now, before we continue, actually, let's go ahead and just plug in that Y2 real quick. 46. Okay. So we already know that the answer all the way over here is not valid, right? That one happens after negative volume, so we can't use any of that part of the graph right there. So we've got this answer and we've got this answer. Now, if you think about this, I am making this box, I'm cutting out these squares, I'm folding this up, that's how I'm making my box, right? What do you think that I'm doing with these little squares? I'm cutting them, and then what am I doing? I'm throwing them away, okay? This problem says, how do you minimize waste? So if you're looking at these two answers, which one would help you to minimize waste? The smaller x value. So minimize waste. So remember, the x value is the size of the squares that you're cutting out. So minimizing waste would mean cut out the smaller square, okay? So we're going to say cut out the smaller square. AKA the smaller x value. So you don't have to write the information for both of the intersections. This is telling you to focus on a specific intersection, and it's the first one. Does that make sense? Because we take the little squares, we cut them out, we throw them away, we don't keep them. Yes? No, they pretty much always phrase it that same way. Yeah. All right, so here we go. We've got 0.638, comma 46. I'm going to do the same thing, second quit, get my x in there. Okay. You could do it by hand. The reason we're not is because those decimals are not very accurate if we do rounded. And so when we do it this way, we're using decimals that aren't rounded. And so it's more accurate, which is why I'm not doing it by hand. So not only is it like simpler to type this and not do it in my head with the decimals, but it's more accurate to not do it with the decimals. Okay. All right. We are going to write just a couple sentences. I'm not going to make you write sentences for all of them. We're going to write just a couple, though. So we're going to say, for the first one, if a 1.25 centimeter square is cut out, the volume is what? Okay. And then here, I'm just going to say volume. Volume. I'm not going to make you guys write all these sentences because they get tedious. All right, what about this one, number 12? What happened here? We have a paper, the width is 8. We are cutting out 4.5 centimeter squares, but the width is 8. So 4.5 from one side, 4.5 from the other side, but the width was 8. Yeah, it's a negative volume because the paper's not even big enough for you to cut out that size square, okay? So this is what we call like an extraneous solution. That's what would be on the other side of that. So these are solutions that show up on the graph, but for the context of the problem, absolutely do not make sense, okay? So we're going to say this does not make sense. Yeah. The paper isn't big enough. Okay. We did a pretty good job already, I think, of writing our dimensions out, so I'm going to let you guys not write sentences for those. Okay, for homework tonight,